So guys, we can get started. So yesterday we looked at how to open Jupyter Notebook or Google Colab like this, the web version of it, and we took a look at three basic things. That is one, output, how we display information from the computer, and then we said that we use the print statements in Python, and then since it is a function, you end it with open and close parentheses, these parentheses, and then you supply whatever you want to display in quotes like this. It can be double quotes like this one, it can be single quotes like this one, or double quotes like this. It doesn't really matter. All that matters is following, putting it in quotes. And then we went on, so we explored this one, we explored this, and yeah, we looked at how beautiful Python is. So that was actually the overview of output in Python. And I'm very sure later on Nanawa took you a little bit further into other stuff. That is where we actually started from. And then we saw that if it is a number, you don't necessarily need to. You don't need to put it. You can actually put it in in a quote, or you can choose not to put it in a quote. And very soon, today, by the end of today, you will know the difference of putting it in a quote. This something like this, and not putting it in a quote. If you don't put it in a quote too, you will know the difference and what's the difference between the two. But the take home thing was, if it is a number, you can put it in a quote or you don't. Any other thing apart from numbers go into quote. So that is what we saw with output devices. Then we went on to see input devices, and we said input statement in Python, how we can feed, whether it's a question or information to the computer. So we saw that just as output is print, input is actually input, and then everything follows. So we write input and end it with open and close parentheses. Maybe let me um, so you write input and then open and close parentheses, and then when you run, you will see a little box where you can type an input, and then when you hit enter, everything is processed. And we were saying that now, if you have something like this, you realize that if you run, there is no instruction to tell the user what to input in the box. So it is better I can input my name, or I can input my age, or I can input my gender. I don't know. So it can be misleading. So instead of, in order to avoid these things, we kind of add a little instruction to the input box to let the person know, okay, we want you to input this particular type of information about you. So if you want to add a description, just like the how we did for the output, the description goes in the parentheses, and it can be in a double quote like this or a single quote like this. It doesn't matter. And then you write the instruction. So for example, what is your gender? And then if I run this, you would see that the box does not only appear, but it appears with an instruction before it asking me what is your gender. So I would know that, okay, I have to put gender in this particular box. So I will say I'm male, and then I hit enter, and I'm good to go. Now we can even go on further to say that maybe M for male and F for for female. So the person would know that, okay, if I am male, I have to just type M, and if I'm female, I have to type, you know, F. So any of them. So this is the overview of our inputs. And then I'm sure when you went on and Anwar told you or he taught you, now if a user inputs information, for example, what is your name? If I input my information and you would want to, so my name is actually Mukailu. Sorry, I don't know why my typing is bad today. And then I enter. Now, if you want to take my name, access the input of the user for maybe future use, you may not have it because you've not stored it in a particular storage in the computer's memory. And that is what introduced the concept of variables. And I'm sure Anamwa did well in explaining what a variable is to you. A variable is simply an electronic container. See a variable like something like a warehouse or maybe a bag, electronic one. In it's not physical like your bag or maybe a warehouse we see physically, but in the brain of the computer or inside the computer where we can actually store some information and pick them or retrieve them for future use. So if I ask somebody, for example, what is your name? I may like to, you know, take the name and save it somewhere so that if whenever I want to know your name, I'll just go into that warehouse or go into that box or bag and then take that name. So to do that, we just so to actually state a variable or maybe declare a variable, you first type the variable name. Let me say name, and then we bring the assignment operator, which is the equal to name, and then I'll say input. So what is your name? And then now what it means is that I'm telling Python programming or the computer that you see this thing. I'm going to ask the person what is your name. Whatever information the person actually gives me, save it in a variable or in a warehouse called name. So whenever I want to access the name the person or the user inputted, now if I go to the warehouse named or the container or the variable named name or called name, then I should get the variable. So for example, if I run this, then nothing changes like before, but if I type Mukailu, which happens to be my name, and I go to a new this thing and I type name and I run, you would see that it tells me it is Mutakilu Mukailu. So it tells me that if you go into the name variable or the name container or the name warehouse, you would find Mutakilu Mukailu in there. Now, the same way, if I rerun this again and then I type or I input a new name called maybe Josephine instead of um, Mutakilu Mukailu, if I rerun this again, you see that now it is telling me Josephine. So now, if you go into the name warehouse or the name variable, you will not see Mutakilu, but now it is what? Josephine. And what makes this nice is that I can save this, and whenever I want to take the name the user actually import or maybe inputted, then I can just call the variable name or I can just type where I saved it and then I can retrieve that information there. As simple as that. So a very simple um, demonstration is here. So now I'm saying that I want to ask the person, what is your name? And then I will save it in a variable called name. And then now I want to print your name is, but I will not put it, maybe your name is Mutakilu Mukailu. But what I'm going to do is I would actually, I would actually, please hold on. So sorry. I would actually, what I'll do is I would actually just call the variable name and then you get it in. Boom, I'll have whatever name is there. So see, if I run this, it asks me, what is your name? And I say my name is Naziha and I hit enter. Now it prints your name is Naziha. Now if I rerun it again and then I say my name is Fridolin and I hit enter, it tells me my name is Fridolin. And then what it is doing is that it is printing whatever is stored in this variable called name here, this thing, and then whenever I call it, whatever is stored in it is what is going to come. Now, that was what you learned. And then I think Nanamwa told you how we name these variables. You know, how we name the warehouses, how we name the electronic containers where we actually save information. We don't name them anyhow. We have three basic rules of naming variables in Python or naming virtual containers in Python. And then, okay, let me call them rules in naming maybe variables in Python. And then rule one is the variable name can only contain alphabets, that is from A to Z. And how did you teach this today? Yesterday, sorry.
Yes, please.
Okay, so numbers and the underscore sign. That is this thing. So variable names can only contain, you know, words that is capital letters from A to Z or small letters from A to Z. I mean, it can contain any capital letter, any small letter, and then it can also contain numbers, any number of a choice, any numbers from 0 to infinity, and it can also contain underscore. This sign here, the underscore sign. These are the only things that I don't know whether I should zoom in more so that I can see it more or it is okay. Okay, maybe this is quite better. Now, the next thing is, or the next thing a variable can actually, or the next rule in naming variables is that after knowing that variable can only contain words or let's say alphabets, numbers, and underscore, the second golden rule is that a variable name cannot begin with a number. So you cannot have a variable name beginning with a number. For example, you cannot have 2x as we see in um, as we see in mathematics, something like maybe two pencils. You cannot have this. So a variable name cannot begin with a number. And then yeah, I think those are the first two are the most important. They are the rules. The last one is more like maybe an add-on, something like a convention. It's not necessarily a rule. It's something good to know. And then that is simply the third rule is that okay, maybe let me make it a rule, or it can fall in the first one. So the last rule is a variable name must represent what is stored. Come on, is stored in it. So, for example, if I am saving, um, for example, if I want to access your name, like we see here, what is your name? Then I don't need to save it in a variable called maybe age. For example, I say age is equal to input what is your name. If I do that, nothing is going to, there is no error going to pop up. Actually, it's going to work fine. I promise you. And then, so let me say my name is Vesta, and then I enter. Your name is Vesta. Nothing happens, or not, no error happens. But you have to know that it is confusing. You and I know that if we are to see age variable or maybe a container which has a sticker on it called age, then we expect to see numbers in it. We expect to see ages in it. So you'll be very, very shocked to go and buy sardine and you open and you see pencils inside. Or maybe you open a milk tin and you see shito in it. Or you see sugar in a milk tin. Or you go and buy a drink, Belacqua Active, and then you taste it and it is maybe blood. Or you taste it and it is, or you open it and you see it is salt. It would really be strange, right? So the same way, you make sure whatever thing you are saving in the variable, the name should reflect that. For example, Since we are saving name in this variable, we would like to call it what? Name instead of age, something like that. So that is not really a rule, but it is good for programming. When you start building your systems and it becomes very complex, it may be very, very difficult for you to, kinda get hold of it. So it is good I mean, uh, you get notes of that, or you get notice of that. Now, let me just show you one thing. Another thing is, I don't want to call it a variable. I don't want to call it a rule. But since I said the variable name can only contain alphabets, numbers, and underscore, it means that you cannot. It doesn't. So if you want, for example, say first name, so you want to ask the person something like input, maybe enter your, sorry, enter your first name. Then, if I want to save this, I cannot say that. I cannot say that. For example, first and then space name is equal to. Now, if I do that, there is going to be an error because remember I said the variable name does not can only contain numbers, alphabets, and underscore. So if you have something like first name or more than one word, like for example, we see a first name, I can maybe combine them like this: first name, no space. Or if it will be very difficult for me to read, I'll do first underscore name. That one, no problem. Or I can go by this. Some people to be called it the camel case naming convention, where the next word, the letter starting the next word will be capitalized, so that I can see like first name. It is clear. Any way you want, that is your choice. I always prefer to go by this convention, first space name. It makes it easy for me to, you know, for me to read, and I'm not forcing you to do that. It's just your choice. You don't need to, do any of that. So it's just something I want you to know. So if I choose mine like this, you can choose to name yours differently, but the whole thing is you obey the conventions and you are good to go. So my first name is maybe, let's say, Mukailo, and then yeah, you see there is no error. But if I had done first then space name, I would have had an error. Maybe let me run it for you to see what I mean by that. So if I do this, you can quickly see that there is a red line under the name, and when I hover on it, see it tells me the error that statement must be separated by new lines or semicolon. And then if I run this, you will get an error, and then the error will tell you that there is a syntax error. Syntax error. When we say syntax is how you write the codes. So it is trying to tell you that there is an error in how you write in the codes. There is something you've done which must not be done. You can see there is a red line underlining this particular line, telling you the error starts from here. So when you realize when I close the errors, the red lines actually vanish, or the red line vanishes. So that is one thing I want you to know as well. This is a good coding practices, like some of the good coding practices you have to know. And when you start it from now, you will not suffer when you start building more things. So that is one thing I want you to know, and I'm very sure and I'm going to taught you about this. And yeah, I'm very glad you did. So if you want to maybe name a variable to with a number, like I said, instead of 2y, you can maybe 2y is equal to 5. You can actually say y2. You can actually say y2 is equal to 5. There is no error. The whole issue is a variable name cannot begin with a number. But if it begins, so for example, if it doesn't begin with a number, for example, I can make it underscore 2 is equal to 5. There will not be any error because it doesn't begin with a number. So that is one thing I want you to do. You really take note of that. Josephine, ask a question. Josephine, you have any question?
No, please.
Okay. Are you getting it?
Yes, please.
Okay, I'm glad you do. Guys, any question or any questions you have? Okay, so let me move on. So one thing you realize is that one thing you realize, I don't know whether you've realized, is that, for example, if I run this code and then I type that my name is Saudi, for example, and I hit enter, now it prints Saudi. Or let me make it this way. Um, I want to print your name is, or let me just, your name is this. I run this and then I say my name is Saudi and I hit enter. It prints your name is Saudi. Now if I rerun it again and then I say my name is Martin, you realize that I don't see Saudi again. Martin is what I see. So where is Saudi? Saudi is gone. So it's like we have a very a big, I mean, storage, but it can only save one thing at a time. So if I am bringing a new thing, then it means that I have to pick the old thing out of the storage, or the warehouse, which is not good. If there is a way we can actually pack a lot of things in a warehouse, then that will be very, very efficient. Imagine you have a very big room, it can take maybe hundreds or thousands of things at this items at the same time, and we can only pick or save just one. It will be quite weird. You can only save one at a time. If you are bringing a new thing, you have to send the old one out. Then it's not effective. That is not an effective way to run things. So we have to explore if there are ways, we can actually save a lot of things in the warehouse at the same time and access all of them at once. So that brings us to a concept we are going to look at today called data types. So today what we're going to do is actually called data types. Now, when we talk of data types, don't get scared. It's simply the type of data, uh, come on, data types. We are just talking about the type of data we can feed the computer with. So you see, so example is you can feed the computer with age, which is number. So we can feed the computer with numbers like money, age, counts. You get it? We can also feed the computer with things like names. You can feed the computer with names of cities. We can feed it with maybe gender, for example, and a whole lot. So that is what we're going to look at. Just that, nothing more. It's just very simple as that. So that is what when we say data types. Remember, I told you data is what you are feeding into the computer, and we know you can feed a lot of things into the computer. For example, you can feed your age, which is a number. You can feed money, which is a number. You can feed gender, which is not a number. You can feed your name, which is not a number. You can feed even a sentence. We can feed two words, three words. You get it? In? So we're going to look at these ones. What are they? How do we properly manage them? And how do we properly save them, in their computer's memory? Yeah, Vanessa.
Okay. Uh, I just want to ask if this is different from what we did yesterday, talking about the integer, the
Now, what did you
strings.
do? And how did you do data types yesterday?
Yes, please. I did the data types yesterday.
So you did list, tuples, and all those things.
Yes, please.
So guys, you know lists, you know tuples, and all those things, right? Guys, are you cool with the list, tuples, and dictionaries? Are you cool with them?
Let's quickly run through them again,
Okay,
if it's possible.
okay, that's very fine. So I'm going to quickly run through them, just like you said. So like I was saying, we have different type of data we can feed into the computer. So we can feed numbers, we can feed a lot of things. So generally in Python, we categorize them into four main, you know, categories. All these ones, all these things, all the names and those things, we categorize them into um, four main groups or yeah, groups. And then the first one we call them, or let me name all the groups and then we just run through them quickly. So we have strings or objects, and then we have um, integers. Those are whole numbers. We have floats. Those are the decimals. The point 0.5, point 0.2, and all those things. Then the last thing is we have collections. So collections are actually a collection of items or a group of items. Let me see this. A group items. So it can be numbers, it can be a group of um, many things, right? So when we talk of strings, strings are just the words, anything other than a number. So okay, let me maybe add one more, which is actually, well, let's regard this as a data type. We call them bool or boolean. Boolean, which is the true or false. And I'll explain why it is um, a data type. So we normally add it to a string, but let's take it as, or we can just put the floats and then the integers together, simple, and call them numbers, something like that. That will be fine. So let me call these numbers. So we have whole numbers and decimals, and we can take this one out. So let's just take this. So we have four main things. The string is just anything other than a number. So when we have things like sentences, the names, your name, I mean, words, and sentences, they are the strings or objects. So if you hear object or string, they are the same thing. So um, they are just like the things we put in the quotes. So if it is not a number, so for example, enter your first name is actually a sentence, right? So it is a string. That is why we put it in quotes. So put this thing in your head. Anytime you are dealing with strings, you put them in quotes, either double or single quotes. So for example, your name is actually not a number, it's what words. So that is why we put them in quotes. So those are strings. It can be just one word. For example, instead of saying enter your first name, I can just say first name, just two words, or I can say simply name, which is still a string, something like that. So whether it is sentence, a phrase, a clause, words, that is string.
great. That has been doing great. That's that one.
And then when we talk of Boolean, Boolean is a type of string, but we don't put them. They are special type of strings that we don't put them in quotes. They are just true. That is true
That's good.
or false.
That's good.
And you realize that these ones I'm beginning with capital letters. So if you write them with the capital letters, capital T for true and capital F for false. Now you see that they are highlighted in blue. Now, but if I do the normal true, you see that it is highlighted in black. If I do the normal false, it is highlighted in. So if I do the normal false too with small letter, you see uh, it is highlighted in black, telling me that that is not a bool. But if you start them with capital letters, then they become Boolean. And Boolean are just true or false, which we will know the use of them later in the course.
Oh,
So,
no.
but it
That's
is
valid.
good you know them. Now, when we talk of numbers, they are just simple. Numbers are numbers. All of us know numbers, whether they are whole numbers like um, 2, 3, 4, and those ones. Like 2, 3, 400, 1,000,000, and all those things. They are numbers. Decimals like 2.1, 2.3, 0.05, and all those things. Those are numbers. In programming, we don't have fractions. We always we always kind of um, what we do is we convert the fractions into decimals. So you see instead of 1 over 10, you see 0.1. We don't have 1 over 10 in Python. I mean, not like you cannot write it, but we prefer to make them in a form of what do you call it? Decimals. Yeah, so decimals and whole numbers together we call them numbers, and you know how to treat them. Numbers are just numbers. We don't put them in quotes, just like you saw there. And if you put a number in quotes, it becomes a string. It is no more a number, so you cannot add it. So, for example, if I do 2 plus 2, we all expect it to be 4, and then we get 4. But if I put these two in quotes and I run, I'll get an error. It shouldn't run, and it tells me that can only concatenate str. Str is a short form of string, not int to string. So what it is telling me is that this is not a number. The first one in quote is not a number. It is actually a string. It is like a sentence. You cannot add a sentence to a word. Sorry, you cannot add a sentence to a number. So if you put a number in quotes, it becomes a string. And what the string means is that you cannot perform some mathematical operations on them. They lose their value as numbers. So if, for example, I say 2 plus 2, will give me an error because the 2 is in quotes. The same way, if you put all the 2 in quotes, you will still going to get error because they are not seen as numbers, right? I think it's very simple that way. So that is the typical example between putting a number in quote and not, or the classical difference between a number in quote and a number not in quote. So just simple as that. Now, if you want to see the data type, whether it is a string, whatever, all you do is you just use type, open and close parentheses, and you supply whatever you want. So, for example, name. And when I run, it tells me that it is str for string. So it is telling me that this thing is a string. Now let's see if I put 2 here. It tells me int. So it is an integer. Int is a short form for integer. Now if I do 2.4 and I run, I get float. Float is simply a decimal. In programming, if you hear float, it means a floating. When we say something is floating in programming, it means that, or in computer, it means that you can assume a lot of values. See it as maybe when you put a bait in on the sea, or when you put something, when you go to the beach and you put something in the sea, the waves will cause it to kind of like float. So decimal is what we call float in programming. So you just so. But if I do true with a capital T and I run, it tells me that it is bool, meaning that it is boolean, and we will know what boolean are very soon when we dive deep into the programming. But now I just want you to know that. Now let's go to what collections are. Collections are just, when we say collections, they are just a group of items. We can, so you have a group of, okay, sorry, someone was joining. Someone was joining, and I think her, I don't know, her listing is, I don't know what she did. It came that I should not admit it. I don't know what she did, but I've admitted it. So back to what you're saying. When we talk of collections, collections are just a group of items. So we have things like you can have a group of numbers, sets. You can have a group of names, all of you, your names together. Then we can have your ages together, or you can have your names and your ages together. So when we come to collections, we have four main types of collections. Actually, we have more than that, but the main types are actually four. And today, that is what we're going to look at. I know you did more through that, but Anawa is going to run you more into it again. So let's look at the types of collections. So we have one. The first on our list is called lists. So you have like our list, a list of items, and then we have tuple. We have let me see, set, and then we have a dictionary. So we're going to look at four main types of collections. So these are what we're going to look at. So we have collections in Python. The main types are lists, tuples, um, sets, and dictionary. And we will see who they are very soon. So just like let's take the first one, list. List is just like the name is just plain English. I told you Python is like plain English. What when we say a list, or I'm going to the market, I've made a list of items I'm going to buy. It can be any item, it's just a collection of items. And then normally when we do list, we have some kind of, if you write your things, let's say you're going to the market and you want to go and buy this. Normally you write them in order. The first one that you write on the paper will be what you really you need most, right? Josephine Abi, that is true. You mostly write the things you need most, like at the beginning, then like more like scale of preference in order of priority. So if you really need onions, you see when the moment you pick your pen or you pick your phone and you open notes, that is the first thing that will come into your head. Like onion, yeah, onion, onion. Then you write onion first and then in that order. So the same thing as list. List is just a collection of items. The items can be one particular item, like maybe names, your all of you, your names together, or ages, or it can be a collection of different items like names and ages, or maybe tomatoes and peppers and cassava and something like that. So to create a list, we create a list with square brackets like this, and then you just supply the variables. So if they are numbers, you don't put them in quotes. If they are not numbers, if they are strings. Now I believe all of us know what strings are. If they are non-numeric, or if they are words, if they are sentences, then you supply them, you put them in quotes. So for example, if let's look at this, let's say numbers, and then each number or each element is separated from the other using a comma. So I can have, so the first element is one. I want to add another element, so I put a comma and then I put the next element two, and then I put the next element, and then I put the next element. So let's say we have five elements, and if I run, I get this. So let's call this maybe numbers. And then So we're storing the list of these numbers in the variable called numbers. So now here, if I come here and I type numbers, you realize that it is actually a list, but no more just one thing. But you can see it's a list of items. Now, if I come here and I add maybe one more thing, like maybe 10 to it, and I rerun, you would see that 10 is added to the list. So unlike first when we had enter your name, and whenever I type a new name, the old name is missing. Here, the list helps us to save a lot of variables together. It's more like you have a warehouse where you can pack a lot of cars or a lot of items into it. You don't need to take the old item which was in it out before you can put a new item in. So that is what a list is like. And then, like I told you, a list actually has what do you call it, positions. So this is the first position, one is in the first position, and then two is in the second position, third position, fourth position, fifth position, and then this is sixth position, something like that. So we, like I told you, we can also have a list of numbers, maybe no numeric. So let me say names. So let's say I have a list of your names. So that will be the first person, let's say Josephine, and I have Fridolin, and I have um, Nanamwa, and I have Ebenezer, Ebenezer, and let me just end it here. Sorry if your name is not in it. Now you see that some of them are in single quotes, others are in double quotes. It doesn't matter. And if I run, if I just print names down here, you will see that it's actually, you know, the names are here. So not just one name, but now I have a collection of names, put together. So that is what list is. It is very simple. We can do a lot of things with list actually. We can add new list, add new thing to the list. For example, let's say I have this list. Now I forgot to add Naziha's name and I want to add. I don't need to come here and then come and do maybe Naziha and then write. I mean, yes, she is there, but if I don't want to, this is not the efficient way of doing it. If, for example, I had maybe the list in a particular database I cannot access, then the best thing I can do is to call the variable in which I stored the list. So, for example, this one I stored it in a variable called names. So I'll call names, and if I run, you will see that names is actually this. So let me rerun this so that we can see that Nazia is no more in it. So it is just Josephine, Fridolin, and Amwa and Ebenezer. So if I want to add Nazia, all I'll do is I'll do the names or the variable in which we stored the list. I write the or I call the variable, I write the name, then I end it with dots, and I add append, and then I open and close parentheses, and I add the name I want to actually add, the new name I want to add, and that is going to be, let's say, Naziha. And then if I run, I don't see anything. Now if I come and now see I print names, you would see that Nazia is added. So that is a way to add, I mean, items to a list. And yeah, we have many of them. You can also delete an item from a list as well. You can do a lot of things. And then when you want to create tuples, another one will take you more. I don't know, did you cover all these things yesterday into details and more?
No, please, we didn't go into details. I just gave them the introduction. Like, yes,
Okay.
it was sufficient
So you talked
examples.
about lists, tuples, and dictionary, right?
Yes, please, but I didn't go into details.
Okay.
It was
So
just the
maybe
examples.
I'm just going to give an overview and hand over to Nanamo, and he's going to continue from there. So this is list. We've seen how list is, and if you want to, we've seen how we can actually add items to a list. And then also the next thing I want to show you is, for example, if you have a list and you want to know the number of elements in the list. For example, we want to know the number of names we have in this names variable, or the number of names we have in the variable. Mind you, we've added Nazia. So if you check, this is the list we have. We want to see the number of elements or the number of names we have in this list. So we have one, two, three, four, five. But if it is very long, maybe we have 1 million, we cannot count by eye. So what we do is, so let's say um, number of elements in a list. Now what you do is you call the variable name list, or sorry, just do len, for short form of length, len, len, and then you provide the variable name in it. So len names. And then if I run this, I get 5. So it tells me that I have 5 elements in the list called names, or in the list which is stored in the variable called names. As simple as that. So if I go and add maybe a new name, let me add Saudi into it, and I run now, you would see that after Nazia, there is Saudi. So I know there are 6 elements now. If I rerun this, I should see 6. So you can see, yes, indeed we have 6 elements in there. Now we can add maybe another name. Let's add Jabir, and then we run again, and let's see. You can see we have them. So Jabir is added after Saudi. And you realize that when you use the append, whenever you add um, a new element, it actually adds to the end of it. It comes to the end of the list so that you can easily see. And it is because list has something we call position. It has positions. They are in order. So they are in positions. The first one is in the first position. The second one is in the second position, like that. So when we run the length, we check the length, we see we have 7. So that is one thing we will have to do. Martin,
Okay. If you want to add any element to the list, let's say the list is number, will you use the same code?
I don't get you, bro.
Like in case you wanted to add think the girl name Jabir, I've forgotten the name. You wanted to add that name to an already existing list, and you
Yeah.
use that code. That was that code. You use a code,
So I use the dot
yeah,
append function
and
or
it was
method.
able to add those things. I'm saying in case it is numbers. In case it's numbers, will you use the same code?
Yeah. So okay, that's a very good thing. So he's asking. So if it is numbers, if it's a number, I can add, maybe let's say I want to add the number 100. I'll not put it in quotes because I want it to be a number. And I'll run this, and then I run, and you can see after Jabir we have 100. And then if I go and check the length, you can see we have 8. So yes, if it is numbers, just like the same, just like if you want it to be in a form of number, you don't put it in quotes. Now if I put it in quotes, nothing will happen. There will be no error, but you will see something. You will see the difference. You would see that the first one, when I didn't put it in quotes, there was no quotes around it. So in Python, this is seen as a number. But because I put the second one in quotes, you can see that, yeah, this one has quotes around it. So this one is not a number. This one is seen as a string, or in other words, like a word like Josephine, Fridolin, and Amwa, and the rest. So that is the difference. I don't know, Martin, is your question answered?
Yeah, it's okay.
Okay, I'm glad. So, Nanamwa is going to take over, and before I hand over, I just want to add maybe few. I want to finish the um, lists, and then Nanamwa will take triple dictionary and the rest. Is that cool? So I want to ask you. If you have any question, you can ask from now. Any questions?
Yeah, I have a question.
Okay.
So, I saw you edited the list by using the, was it append or something like that?
Yeah.
Is there any shortcut where we can use something else if we want to delete maybe a number of elements from the list?
If you want to delete.
Yeah.
Okay.
In
So
case you
that's
have 1,000 lists or elements in a list and you want to delete particular ones, but you didn't want to go through all to
oh,
locate
okay.
which one to delete. Is there any shortcut like the append? Like, was it append?
Yeah, the
Is there
append.
any
Yes.
shortcut that you can delete something from the list instead of going through the whole list? Like,
Okay, that's very fine. So let's look at that. Yes, there is. So let's look at this list. Let's say we want to delete Josephine because she asked the question. So we want to delete her from the list. So Josephine, sorry, we want to take you out. Okay, we are taking you from the list. Is that fine? So let me maybe scroll it to the top so that the same way like we used append. So you call the variable names and then you dot instead of append. If you want to remove, we do dot remove, and then you can do Josephine. Remind you, if you are removing, make sure that your spelling is the same as the Josephine, how Josephine is spelled. Josephine is spelled with small letter J and you make it capital J. It's not going to delete Josephine. That's one thing you should know if you want to go by this approach. And then we, before, let me do names so that we can see. So now I run names dot remove Josephine. And you can see at first Josephine was the first person in the list or the first name in the list, but Josephine is no more because we said we want to delete Josephine from the list. So the same way we can delete, the same way we can add elements, we can also delete elements from a list. Josephine, is that cool?
yes, please, it's fine.
Yeah. So we've seen, I think, yeah, we've seen how we can delete um, what do you call it, items from a list. And don't worry, we would look at how we can delete um, a lot of items too. But don't worry, let's just take our time one at a time, right? So that all of us can be on the same scale. And then when we're moving, we move with vim and nobody is going to get hurt, right? So I want to, let me add Josephine back. Josephine, should I add you back? So I'm adding Josephine back. And if we check now, Josephine should be in the list again. But the thing is, Josephine is no more than number one. That is very sad. Now, I told you the list has um, positions. So the first person, Fridolin, is now in the position one, and Anamwa is in position two, or the second position, the third position, so on and so forth. But in Python, there is a special way of positioning. Instead of counting from one, starting from one, we start from zero. So Python is what we call zero indexed programming language. Zero indexed programming language. Let me type it here. Maybe so it is called let me bold in this. Python is called zero indexed um, zero index programming language. And what that means is that it starts counting from one. It starts counting from zero. Sorry. So instead of starting counting from one, as we do, if you are in position one, Python actually see you to be in position zero. So right now, if you want to know the position, Fridolin is in the first position, all right. But in normal common sense or in our daily life, first is always one. But in programming or in Python specifically, other programming languages go by the one, two, like our normal this thing. But in Python, the first person is in the position zero. So the second will be in position one, position two, position three, position four, five, six, and so on and so forth. So if you have eight elements, then it means the last one will be in what? Seventh position. Since the first one will be in zero or zeroth position, something like that. So, with that being said, if I have a list, for example, the list of elements, the list of names like here, now I want to know the person in the first or in a particular element, sorry, in a particular position. Let's say I want to know who is in the first position. I don't need to go and then look at Fridolin. Imagine we have 1 million and the data is something we cannot even view. Then we would have to um, there is a way to actually do that. Josephine, Josephine, your hand is up. Any question? Any question?
No, please.
Okay, that's fine. So let's look at how we can actually access maybe the element in a particular position without necessarily going to look into the list, because imagine this is just a practice. That is why you see maybe eight names, but in real life, if you're working as a data scientist or maybe a business person, you have maybe 10,000 customers and you want to look at the person in the 1,500 position. Are you going to scroll and be looking through? No, that's not the efficient way. So now let's look at how we actually access a particular element of or a particular element in a particular position of a list. So we're going to use our names list. So what you do is you call the variable name, that is in this case names, and you end it with square brackets like this, and you provide the position. So if the person is in first position, I said Python is zero index or zero indexed position programming language, meaning it start counting from zero. So if you want to see the first person, then his or her position is what? Zero. And if I run this, you see beautifully, it would give me the person in position zero or in the first position, which is Fridolin. So the same way, if I want the second person, it's actually going to be in position one, and that we expect it to be Nanamwa, and boom, it is Nanamwa. If I want in the third position, that is going to be position two, because zero, one, two, something like that. And then boom, we are good to go. So it's something like that, just simple. So if I want the last one, I have to know that they have eight elements. So the last, since we start counting from zero, the last one will be in what? Seventh position. And then I run and I'm good to go. Now let's see what happens if I by accident click um, 8. I get what? Josephine. Now what if I click 9? Let's see. It tells me list index out of range, meaning there is no ninth position in here. So something that is one thing I want you to know. So now the easiest way to find the last element of any list of any sort, if you want to find the last element, then you just do the last element is always negative one. Sorry, you just make negative one like this. It will give you the last element, irrespective of the size of the list. If you just do name of the variable square bracket negative one, it gives you the last element. And then very maybe later we will know why it does that. It does that. So that is one thing I want you to know. A trick is if you want the last element, you don't need to go and ask yourself how many elements, then you go and subtract one from it. You just do names or the name of the variable, in this case, name square bracket -1, and you are good to go. So if it is the first one, you don't forget, we start counting from zero and so on and so forth. Now, we've seen how we can access a list, sorry, an element. How do we also access a list of, you know, elements? We don't just want the first one, but we want the first and the second one, the first and the second elements, not just the first. So the same way we do names for the variable name and its square bracket, but instead of just position zero, making it position first position, giving it index zero, we want the first and the second. So we provide the start and then we provide the end. So we give colon, something like we 0:1. What it means is that we want from the position zero, that is the first position, to the second position. And then let's see, boom, we get only one. And the reason is that in Python, the last element is always excluded. So if you want the first and the second, instead you give 0 to 2. So you give in excess of 1 so that the last will not come. So it's always like +1, something like that. Did someone ask a question? Martin.
Uh, Mr. Cleo,
Yeah, go
I
ahead.
use for the list. I didn't use names for that. For your example, I use the first example. You use numbers from 1 to 5, and
Okay.
I try applying the same code you use, but I don't know. It's giving me error.
Yeah,
Uh,
it's
Instead of
because.
using the name,
Okay, so what's the. Read the error to me, the last line. What is it?
uh, it says name into bracket name is not displayed.
Is that what?
Name number is not defined.
Is it, did you use numbers or number?
Okay. Let me check. Okay, you see me, I use number.
Yeah, so if you used numbers, make
Yeah,
sure
yeah,
you
yeah,
do
yeah.
numbers. Yeah.
I've seen the problem. The
Okay.
problem is coming from my side.
Okay. Thank you
Thank you.
very much. So, guys, that is it. This is how we can access multiple and single this thing. I'm recording a special video on it, a short one which kind of tackles all of them for you, which would be soon. I know, had it not been my sickness, it would have been out by now. I'm still editing this thing, but because I'm sick, I couldn't, I haven't been able to work on them. I just want to end here, take your questions and pass it over to Nanamwa. Nanamwa will continue from here. Nanamwa, you will take it from how to access. I think I've almost, or let me just exhaust where the last thing on it. So if you want to access more than one element, that is what I just gave. So zero, so 0 to 2. So it's more like if you have 8 things, it's going to be like the first one is index 0, the second one is 1, third one is 2. But we realized when I did 0:1, which is to say give me 1 to 2, give me only the first one. What that means is that Python does not include the last element. So if you look at from the range 0 to 1, that is, it's going to be, if you look at the list, it is actually going to be Fridolin and Nanamwa. But it will not include the last one, which is Nanamwa, in the range I gave. So always, if you want Nanamwa and Fridolin, since it is not going to add the last one, then you have to index it or give a range, +1, something like +1, so that it will not include, because you want Nanamwa and Fridolin, it would not include Ebenezer, and then it will give you the first two. So it's more like the last is not included, the last index is not included. That's something I want to share with you. So now the last thing I want to talk about a list is that since we know how to access a particular element in a list, then we can use that technique to kind of like change a variable. So let's say, or change an element. Please hold on, let me finish before you ask a question. So you can actually change a particular element in a list. So for example, let's say the first element is not, or the first name is actually not Fridolin, but it is maybe Freddy or Frederick. So we misspelled it. Or maybe it is actually not, let's say we misspelled it. Instead of Frederick, we said Fridolin. Now, we know that if I want to access the first element of the list, all I'll do is to just do names and then I do 0. And then that is going to give me Fridolin, right? So if I want to change Fridolin or the name at the first position, all I do is I call it like this and I assign break equal to and then I give whatever name I want to replace it with. So let's say Frederick. So I want to say that I'm telling Python that go into the list, store in the variable called names, pick the first element, and then instead of what is there, pass, replace it with this thing I'm giving here. That is Frederick. And then if I run this, you would see that the first name has actually been changed from Fridolin, which we saw here, coming Fridolin, which we saw here, to actually Frederick down there. So that is one thing I want you to take note of. So you can actually change a particular element in a particular position using this kind of approach. Please, who asked the question? Sorry, I had to finish it. Take it. Who was asking the question? Yeah, Martin, go ahead. Go ahead.
Okay, Mr. Q.
Yeah, you
Okay,
want to
for
ask? Just
Yankee.
ask a question.
Okay, okay, for Yankee. As I said, I was using the numbers for the list, and I was trying to substitute six. I was trying to add six to the list, and the error that came was like it came as real. They were saying tubu object does not I support the item, something
What
like that.
object? Tuple.
Uh, let me rerun it. Okay, let me rerun it again. Then I'll get back to you.
No, read the error to me so that I can know your problem.
Okay,
Yeah, what's the
you
error?
feel like I clean it. So let me.
So is it
But if
okay?
you can go over, I will do it and I'll get back to you.
Okay, thank you very much. Josephine, you raise your hand up. Josephine, you raise your hand up. Any question from any other person?
Okay, okay, here is the problem. Okay, the error was like tubu object does not attribute append.
Tuple object. Tuple, right?
Yeah.
So your problem is when I was teaching, I said that you actually we actually dealing with list, and to create a list, we use square brackets. When you go to the numbers, you see that you used instead of square bracket, you use parentheses, the C brackets. That is a tuple, and that is not a list, right? Go and check.
Okay.
Have you seen that?
Mm, yeah, parenthesis. Parenthesis.
Is it a square bracket?
No, I use parenthesis.
Yeah, so that is a tuple. That's the next thing we're going to move on to. Tuple, that is the, so we would get there. but you've seen where your error is coming from, right? So when you
Mm.
change parentheses to square bracket, you should follow. So you were doing tuple instead of what do you call it? Instead of the list we were doing.
I think you should. Okay, 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 okay.
Is it working?
Okay, okay, okay. Okay.
Yeah.
I
Thank you
think
very
I
much.
should go with it.
Thank you very much. Any other question? Yeah. Josephine.
Let's continue, please.
Okay. Fridolin, you raise your hand up. Is there any question? If you have any question, Fridolin, anytime you can just anytime your network is true, you can just pop up and then speak. I'll pause and listen to you. Any are we cool? Does anyone have a question? You can actually ask me.
Hello.
Yeah, Fridolin.
Hello.
Yeah,
My
we can
question
hear
is
you.
like from before. You see, when you did the name, maybe input what is your name, and then print your name is the input name to get like your name is the name.
Yeah,
I when I did it, they were also like simple object is not callable. I don't know if it's because I'm supposed to use a box bracket or something.
I don't get it. Is it something
So
like?
that's I didn't really.
Is it something like? Is it the first side where I
We
did
did that.
name?
Yes,
Something
yeah,
like name is equal to um, input. What is your name? Something like that.
yeah.
What is your name? And then I did print. Your name is, and then I did this. Or is it this one? Is it this one? Fridolin, are you there?
And that's like, yeah.
Fridolin, are you there? We can hear from you now. Yeah, so you can talk. Fridolin, are you there? I can hear from you. You can talk. Fridolin. Okay, so guys, I think his network isn't true. Let's move on. Any other question from anybody? Any questions? Okay. Martin, I guess you.
Yeah, but when I do it, they say simple object is not callable.
Fridolin, I mean, do you mean what I've done there? Fridolin?
Yes, this one.
The same thing I've done. The name is equal to input. What's your name? Fridolin, please, can you hear from me?
Yes.
So I'm saying, is it what I just did? Name is equal to input. What is your name? Print your name is this, or which one? I guess you can type your question, and then because of time, we move on. Right. So you can type your question, and then
Hello. Can you hear me now?
here we can hear you, please.
Yeah.
I mean, it's the network. I think you are off again. We can't hear you again, to be honest. So I guess Fridolin, maybe you can ask in the group, or maybe you can type a question. Because of time, we're moving on. Um, so guys, that is it. If you don't have any question, let me proceed. So we've talked a lot about lists, and we've seen how we can create lists, how we can um, actually, add new items to lists, how we can actually remove items from lists, and how we can, um, kind of like, yeah, also change a particular element or access an element in a particular position. We've seen the positions, how they are indexed. They are called indexed, how, or let's say the index or the indices of the the list. We saw that Python is zero-based programming language, and that is, it starts counting from zero. So the one with the in the first position is actually in position zero, something like that. So now the next thing, and then we've seen how we can actually change a particular variable in a particular position, like we just did here. Now let's move on to tuple, and then probably we call it a day. I don't want to bombard you with a lot of things, so that tomorrow we can take it from, on Wednesday, or maybe the next weekends we can take it from there, something like that. So with tuples are just easy, just like lists. Tuples, the only difference between, or the only thing between, the only difference actually between a tuple and a list is that for a list, it is created using a square bracket, but for a tuple, we create it using parentheses like this. So any other thing holds. So we can have Josephine, we can have Nanamwa, we can have Fridolin, and others, just like that. And we can append, we can actually add. So let's say if we store this in a variable called student names, student names, then we can actually, so when Martin, I guess you have to mute yourself. Student names. Thank you very much, Martin. So student name, and we can see that we can add items. So add elements to a tuple, just like a list. Any other thing we did to a list holds, except few things I'll show you. So if I do students names dot append, maybe I want to append a new name, that is maybe Vesta, then it should work. Now it tells you that tuple object has no attribute what append. So with tuples, it is quite the difference between tuples and then list is that with the objects you cannot iterate them, right? Meaning you cannot manipulate them. Once you define them, they are just like that. You cannot manipulate them. So unlike lists where we can actually um, change some items, or maybe you can add new items and all those things. I'm coming. I think it's actually, it becomes quite for tuple. Once you define them, they don't want, you cannot iterate them, you cannot change them and all those things. So that is one thing about tuple, and we will see the importance of that thing it has. So that is one thing you know about tuple. Any other thing holds. For tuples, you cannot manipulate the items. They are fixed. So unlike lists which are flexible, um, you can maybe change, you can add and delete and all those things. For tuples, they don't allow tuples don't allow themselves to be, for their elements to be manipulated. That is one thing you should know. Okay, Josephine, any question? Okay,
Let's
I
move
think
on, please.
okay, that's very fine. So tuples are like lists, but the only thing is we cannot, we cannot kind of like manipulate um, their elements, and then yeah, that is the only thing. Tuples have their goodness, and when we come, we start the real programming, when we start the real data science stuff, or even in the other lessons, you would see the importance of or the use of tuples, which is very very important in some cases. But I just want you to know that there are tuples, and this is what tuples are, and this is the real difference between tuple and then a list. So with tuple, Mr. Ebenezer, I'm coming with tuples. They are just like lists. The first difference is that for list we use square brackets, and then for tuple we use the parentheses. And then another thing is for list it is very flexible. You can delete, you can add, you can do a lot of things. But with tuple, it doesn't allow for those things. Mr. Ebenezer, you can ask a question.
Okay, thank you very much.
You're
And
welcome.
from the beginning, we learned the naming conventions for variables.
Yeah,
Now we agreed that we can include underscore when we are naming variables.
yeah,
So, for example, when we're doing the list, the variable name was names, and then
yeah.
for the tuple, students underscore names. Is it the underscore that is making it a tuple or what?
So like I was saying, the
Yeah.
tuple, you see, it is here. Look at here. When it is a list, you see that a list is defined by square brackets. Have you seen? But a
Oh,
tuple
yes, yes, yes.
is defined by this. So that is what makes it a tuple and not the names underscore something. So it is the if it is square bracket, if this was a square bracket, for example, if I change this to a square bracket and I go here and change this to a square bracket and I run, now it becomes a list, right? And if I run this, you see that it works. Vesta is being added. But if I change and if I even do here, let me make this, let me check the type for you. So if I check the type for you, it tells you that this is a list because it has square brackets. But the moment I change this to a tuple, to parentheses, the moment I change this to a parenthesis and I run, it tells me it is what? Tuple. So it is the parenthesis and the square bracket which makes the difference and not maybe the naming convention. That doesn't matter at all. Is that cool?
Thank you very much. Thank you very
You're
much.
welcome.
It's well understood.
Sure. Any other questions from anyone? I feel like we've had much we are today's section is quite short but packed with a lot of things. So I don't want to be adding dictionaries and all those things so that it will be hard for you to learn. Or what do you think? Should I add that one? Or maybe we should take this and digest this and master this for now. When we meet again, then we actually get to, I mean, a lot of things. What do you guys think? Josephine, what do you think? Martin, do you think we should continue with more other concepts or you think we should just.
So, as for me, the way the lesson is going, I would love us to continue, but I don't know for the rest.
Oh, okay, so you're enjoying it, right?
Yeah.
Okay, so Josephine, what is your say to? Okay, so Josephine is
Um,
not there. Okay,
I'm here. I think we've had enough for the day. Me, I've had enough for the day. I cannot speak for the rest of the class.
okay,
But
that's fine.
whatever the decision is, we can take it.
That's very fine. Stabilizer, what do you think?
I'm also okay with whatever decision the class will take.
Okay, that's very fine.
Besides, the time is like almost ending. We have
Yeah,
about
that's true.
15 minutes.
That's very true. Naziha, what do you say? Okay, so I think I would side with um, Josephine, not because she said this thing. Okay, Fidi Kitchen, what do you have to say? I don't know whether it's Saudi or um, it is Saudi. I guess she's not hearing me or something like that. So, guys, I think I have to side with Josephine. I know it's not about teaching all the concepts in one meeting. It's about my goal is for you to understand, for you to be able to understand this and apply them in any concepts. And when it going gets a little bit tougher, right? So I would like us to end, and then you can digest your what we've learned. I think we've had much today, very technical, and I know you would do much. You would do um, I mean, you would go over till we meet on Wednesday, and then maybe we discuss the career session, and then weekends again we continue our coding. So what is left on our list is actually dictionaries or dictionary and then set. A dictionary is just like I mean sets for sets. We're not going to go deep into that. It's not really useful in programming in Python, for example or let's say emphatically. And we will spend some time with dictionary and then we go to go, we'll move to the other concepts. Now, in your revision, if you don't get anything, you can go to YouTube, like I told you, and you can always watch videos. If you type maybe lists in Python, you have a lot of like millions of videos you can watch. Maybe somebody or another person's approach may really help you if you're not getting this well. And then I'm also going to upload the video, you know, in the course of the week. I'm sorry for not being able to um, upload the previous ones. You know what happened? I was quiet, no well, so that is why. And then I'm working on, doing some little short videos to summarize these things too for you on there. So please, I'll urge all of us if you've not subscribe to the YouTube channel, do well because if I upload something, I don't need to come and tell you the group that hey, something is uploaded. You should have a notification and you go and join. It won't take anything from you. It's a way of also supporting Homeschool Academy and then you like the videos there. If there is any question, you just leave a comment there. You can watch the previous sessions we've had before too as well. So if there is any question, you can ask. If there is no question too, I would like to call it a day. And thank you very much for joining. Have a good night, and I'll see you on Wednesday. If you have any question, you can ask. If you don't have a question, you can yeah, leave.